Hello everyone. In the previous video we talked about using pointers in relation to structures, and we had a structure representing complex numbers, and we were able to create a pointer to a complex structure and dereference it and access each specific member. We had two ways of dereferencing it, and here I'm going to show my preferred way of dereferencing a pointer to a structure with something called a linked list. And something that's really interesting that pointers let us do is that it lets us abstract concepts and things. It lets us try out abstract concepts that we normally couldn't do if we didn't have pointers. So let's start by creating something called a linked list. So here we have a structure. It's called linked list underscore linked list. It has two members, an integer called value, and something peculiar here is that we have a pointer, a struct linked list pointer. It's called next. So this has the potential of pointing to itself, which at the surface seems quite useless. Why would you want to point to yourself? Well, we can use this manipulation for pointing at copies of this data type. And here we'll show some quick and light example with that. Here, I'm going to do a type definition so that way I don't have to write struct underscore linked list all the time. I can just write linked list. So what I'll do is that I will create what I like to call a node of a linked list. And I'll call this L1. To say linked list L3 and linked list L2. Now here what I'm going to do is that I'm going to create my structure with data here, and I'm going to write null here. So what does null mean in this context? Null means that it points to essentially nothing. We're kind of marking an invalid variable. And in this context, maybe you might remember from learning about characters and strings, but null can be seen as is essentially equal to the backslash character, the backslash 0 character. These are both the same values. Null is a little bit more general. You use it with pointers. Right, the backslash 0 you use with characters, with strings, that kind of thing. But for pointers in general, you use null. So here what I'm going to do, well, this is going to be a linked list. And what does it mean to be a linked list? Well, each one of these nodes or variables of a linked list, they're going to contain addresses to each other. So I can type this. Right, now L2 has a connection to L3. It has the address of L3. So since L2 has the address of L3, we also have access to L3 because through using dereferencing, we can access L3. But you know what? I don't want to keep it like this. I actually want to connect L1 to the front of everything. So I will say L1 dot value equals, let's say 1. L1 dot next is going to be equal to the address of L2. So we kind of have something like this. We have a variable, we have L1, below the L1 is going to be the value, and the next is denoted by an arrow. And then L2 has the 2 value there, and then we have another arrow which is pointing to L3. Right? So then we have L3 which has the value of 3, and then its other arrow which points to null. So these are structures that are loosely connected and pointed to each other. And right, these pointers to itself as a data structure allows it to create a link between one of these structure variables to another. Right? So it's a curious way of creating an array. if I have a linked list like this, what can I consider L1? L1 is the beginning or the head of the linked list. And L3 can be the tail or the end of the linked list. So typically when you're doing work with linked lists, the most important variable is the head, where it starts. And I would say the second most important variable is going to be the tail, where it ends. The idea is that you can, with linked lists, is that as long as you know where the beginning and the end is, it doesn't matter what's in between. You can do a lot of manipulations with this list, and you essentially have an array that you can dynamically add to. As you may know, when you create an array, that's static. It doesn't change. So having something here like a linked list is really nice because it's dynamic. Because as you see here, all I need to do to add to my linked list is to have it connect via the pointer called next. So how can I go about printing a linked list when I have the head? One of the best ways of going about it is, since we're messing with pointers, we should be a little extra careful. So what I'm going to do is that I'm going to take a copy of my head, which is going to be like this. I'm going to assign L1 to temp, and then I'm going to say while temp does not equal null. Okay, well, temp does not equal null. I'm going to do this thing. I'm going to print the value that's stored in my structure, and I'll give it a space. And I'm going to say temp, and I'm going to dereference, and I'm going to access value. I'm going to dereference my pointer to a structure so that way I can access the individual member value. And the next one I'm going to do is I'm going to say temp is equal to temp, and I'm going to dereference it, and I want to go to the next one. So this is pretty cool because first temp is going to be pointing to L1, so we'll have access to L1, meaning we have access to 1 and the address of L2. We're going to print temp value. Well, what's value? Well, value is 1. And then here we're going to assign temp to temp next. So why does this work? Well, temp is a linked list pointer. So what's the data type of next? It's also a linked list pointer. And where does next point to? Well, next points to the address of L2. So now we have access to L2. Now temp is pointing to L2. Now, since temp is pointing to L2, if I want to access temp value, well, temp value for L2 is going to be the number 2 here. And then if I want temp next, well, what's temp next for L2? If we look at L2, the address of L3 is going to be next, the next member for L2. So then the address of L2 now becomes the address of L3. So at this point, neither L1 nor L2 nor L3 equal null because they are valid linked lists. So right now, we've looped twice. The first loop iteration we were L1. The second loop iteration we were L2. Now we're at the stage where we are in our third loop iteration and we are L3. So L3 is going to have its value accessed. Well, what's the value of L3? It's the first member of the data structure. So it's going to be 3. Then we're going to say, okay, temp is going to be equal to temp next. Well, what's the next? What's next here? Next is null. So now temp is equal to null. And oh shoot, well, this is true now. So we're done with the while loop. So why don't we see the consequences of this? Why is this so upset? Ah, that's because I spelled it liked, not linked. 1, 2, 3. Right? So this is really, really cool. if I wanted to now, I can say linked list, and I will say head is equal to 0, and the address of L1. I can copy this. Actually, I can reuse temp, and I need to fix my while loop. Temp is going to point to the address of head, and then we're going to access the data again. And I'm actually going to clean up my code a little bit. I'm going to print a new line here, copy that, print that here. Okay, not so bad. Let's run this. Okay, this looks a lot better. This is actually pretty cool as well. Here we've added 0 to the beginning of our linked list, just like that, willy-nilly on the fly, which is pretty cool. And one of the greatest benefits for linked lists is that now we have a data structure, because we consider arrays a data structure. We now have a data structure that we can add data to dynamically, meaning on the fly, which is really, really cool. However, one thing that I'd like to talk about is that, man, having to rewrite this while loop over here twice when we're not really changing much is kind of annoying. So in the next video, why don't we talk about using pointers as inputs to functions? Thank you.